Hello, everybody. So today we're going to look at a little bit more complex operations with complex numbers. We're going to specifically look at multiplying and dividing them because adding and subtracting them works just like adding and subtracting other numbers. And we'll kind of deal with them as we go through multiplying and dividing. So when we're multiplying two complex numbers, it actually works the exact same way as when we're multiplying like two binomials. These are binomials as well, and so we can just multiply them out. 2 times 5 is 10. 2 times 2i is 4i. 3i times 5 is 15i. And 3i times 2i is 6i squared. Now the thing is remember, we want our answer to be in the standard a plus bi form. So I got to combine my like terms. 10 plus 19i. And remember, I squared is -1, so this is actually a -6 at the end. So 10 minus 6 is 4 plus 19i. Okay. So again, you want it to get it down to this. You don't want exponents on your i's, and you don't want more than one I hanging around. All right, let's try this next example. 5 times 5 is 25. 5 times -3i is minus 15i. Positive 3i times 5 is plus 15i. And 3i times -3i is minus 9i squared. So the positive and negative 15s, they'll cancel out. So I'll have 25 minus -9. Remember, I squared is -1. Minus negative is adding. So that's 34. This one worked out to a nice real number, which is cool. I think it's awesome when we can multiply two complex numbers and it ends up being totally real. You might have also noticed that the 5 plus 3i and 5 minus 3i, that's a special case, right? Like that's the same numbers, but the signs are opposite. So we call these complex conjugates. Right. So complex conjugates are two complex numbers with equal a values, but opposite b values. Okay. And conjugates don't have to be complex. They can be radical. It's anything where we do that, where we flip the sign of the second term. It's actually going to be very useful for us because you'll notice that these those middle terms, it ended up getting rid of the i's when we multiplied by them. So that'll be important later. So when we're dividing by I, we need to make sure that there's no I in the denominator because remember, I is radical -1. And that means we have a radical in the denominator and we can't have that. So sometimes you can just look at this and be like, oh, the i's cancel out. This is 10/8. So this is 5/4. Cool. Sometimes you can do that. Other times we can't cancel out the i's. So we have to make it so that the I disappears. And just like before, we're going to multiply by I on top and bottom. We don't need to multiply by 3i, just I, because there's no other radical. 3 is not a radical, so we can leave that down there. So that'll give me 4i over -3i squared. I squared is -1, so I think you see why this works, why that's our strategy. So 4i over +3 then. Because -1 times -3 would give us +3. Here you could, it depends on the order you do things in. I would kind of start by simplifying this out, right? That you can get rid of the I on top and bottom, and now you have -8 over 2i. So this is just -4i. Again, here I would do the same thing where, remember, if you have a radical on top and bottom of your fraction, you can cancel out within them. So we can take a factor of -5 out from the top and the bottom. So that'll give me 1 and 3 here. So I have 2 over radical 3. So I multiply by radical 3 on top and bottom. 2 radical 3 over 3. Here, now these next two examples, what I need to point out is that these problems look really similar, but they actually have different answers. The square root of -2 times -8 is, the square root is 16. Negative 2 times negative 8 is positive 16, which is 4. However, when it's split up like this gives me I radical 2 times I radical 8. And I'm just going to go ahead and I times I is I squared, radical 16. Radical 16 is 4. I squared is negative 1, negative 4. Now, the reason why we get two different answers here and we can't just like combine them from the first step is that you'll remember that earlier in this unit, we talked about that for all a and b such that a and b are elements of the real numbers and ab is a real number. These rules, they worked for real numbers, and we're not dealing necessarily with real numbers anymore. So we need to be careful with that. That it's not necessarily a two-way street anymore. So be sure to take your eyes out if you're multiplying first, okay? Especially when it's like that. You might lose the sign. Okay. If we're dividing and we have an expression in the bottom that is like a binomial expression, it is not just I or 3i, it's like 2 plus I or 4 minus I. This is when our complex conjugates come in. So a complex conjugate, remember, is just when we are keeping the a value the same, but flipping the sign of the b value. So I'm going to go ahead and do that and do 2 minus I on top and bottom. The reason why the conjugate works here is because you'll remember earlier that those I terms, those purely imaginary terms, dropped out when we multiplied two complex conjugates. So this way that in our denominator, our imaginary values will drop out because then my I squared will become real. So here, I'm going to have 3 times 2 is 6. 3 times negative I is negative 3i. 2 times 2 is 4. Remember, I'm going to have plus 2i minus 2i. I'm just going to ignore those and do minus I squared. So I have 6 minus 3i over 4 plus 1, which is just 5. So I have 6/5 minus 3/5 I. Remember, I want to split it up. I always want to write this in the format a plus bi. Okay? I can do the same thing here. So my conjugate here would be 4 plus I. 3 times 4 is 12. 3 times I is plus 3i. 2i times 4 is plus 8i. And 2i times I is plus 2i squared. All over. 4 times 4 is 16. 4 times I is 4i. Remember, these middle terms will cancel out, so we don't really need to worry about them. Then we'll be subtracting I squared again. So here I'll have 12 plus 11i minus 2 over 17. So I'll have 10 over 17 plus 11 over 17i. Okay. We can even solve equations with these guys. So we would solve the equations just like before, but if we were to get a negative in the radical, like we might have seen earlier, we just simplify it as normal and express our answer in terms of I. So here I'm going to divide both sides by negative 2 first, and I'll get x squared equals negative 5 halves. If I radical both sides, right, x equals plus or minus radical negative 5 halves. So x would equal plus or minus radical 5 over radical 2, and I just took out, because the negative, it doesn't matter if it's in the top or the bottom, right? I'm just going to take out the I to start. And now I just need to rationalize, right? So times radical 2 and radical 2. So x equals plus or minus I radical 10 over 2. You'll notice that if we have a radical and an I coexisting, we normally write the I in front just so we don't think the I is under the radical, and then that's like the square root of I, which would be like the square root of -1, which is a little too deep for what we're doing right now anyway, and also not what we actually just got as an answer. So just be wary of that. All right, here, our first step should be to divide that 3 out first. Remember, you can't distribute that 3 in because of the exponent. You can't multiply before you do exponents. So we divide the 3 out, and we get x minus 4 squared equals -16. We'll take the radical of both sides, square root. X minus 4 equals plus or minus, the square root of -16 is 4i. And now I just need to add 4 to both sides, and x would equal 4 plus or minus 4i. So if we were to plug 4 plus 4i into our original equation, we would get -48 when we do 3 times 4 plus 4i minus 4 squared. It would still work out. Okay, one more video on complex numbers, guys, and then that'll be it. Thank you so much and have a great day.